Hey, everybody. So cool. Let's get straight into it. I'm just going to say I put a pair of Twitter handles on here on this first slide. So please follow me on Twitter, following Guardians. And cool, let's get right into it. So here's what we're going to do today. I'm going to do a quick kind of intro / review about what a pod is, what a node is in Kubernetes, kind of like relate that to containers. Then we'll do some attack, and then we'll talk defense. We've got a tight window here, so I may talk a little fast, but hopefully not too fast. Cool. So real quick, Kubernetes. If you've never heard of Kubernetes before this, you should be able to follow some of this, but it'll be a little hard. But I like to throw a little review in because so many of us haven't played with Kubernetes yet. So Kubernetes is basically kind of its intent is to give you a software-defined data center via container orchestration, and that data center can be just for one application, or it can be for a whole lot of stuff. It's a kind of a great way of being able to scale the amount of compute resources of virtual machines and so on to what you're doing, to what you need at any given second, as it were. So these are kind of the kinds of things it can do. I've put on this left side the biggest issues, basically, that it assigns work to machines. That's, you have a container you'd like to launch on one of many machines. It figures out which one to put it on. It's kind of cool that you tell it what the state of the world is that you want. You're like, hey, I'd like at least 3 copies of this. I'd like them to run on as many machines on 3 machines or more, ideally, so that if one of those machines falls down, crashes, everything's still good. I'd like that to horizontally scale. So I want 3, but if things get really busy, I'll go for up to, say, 100. You take care of all the scaling up and scaling down as needed, and all kinds of cool features. I give a lot of talks on Kubernetes, as do a bunch of other cool people. Not saying I'm a cool person, a bunch of people who are much cooler than me, and you can learn more about Kubernetes and its security implications from those. The 2 things I want to kind of tell you about real quick are, if you're new to Kubernetes, you'll be like, he keeps talking about pods, but I thought Kubernetes was about containers. So basically, Kubernetes organizes containers, organizes the work in pods. So if you want to stage a container to Kubernetes, you basically create a pod with that container in it. And a pod runs some containers. It might have some volumes, which are some storage. And a pod has an IP address, and it's a different IP address from the node that it's running on. Kind of funky trivial thing is that trivia is, in this case, is that all the containers that are running in a pod all share the same IP. They share the same localhost. They can't all listen on port 80, as an example. We're not really going to use that, so I'm going to keep going. The next part is I'm going to use the word node a lot, and what you need to know about node is a node is a machine, whether it's bare metal machine or more often a virtual machine, that is part of a Kubernetes cluster. And a node, in order to be part of the Kubernetes cluster, kind of needs 3 components. One is it needs a container runtime that could be Docker, Containerd. It needs some way of basically staging containers. It needs a kubelet, and that kubelet is part of Kubernetes. Kubernetes kubelet. It's this thing that has an API. You can REST API to the kubelet and ask it to do things, and it's kind of the point of contact on a given node in the cluster. So it has to be able to do things like watch to see what pods are supposed to be running on it, and so it'll have to be able to get information about what pods it's supposed to be running, and then tells the container runtime what to run. And so it needs some privilege for that, and that's why we're talking about it here. Kubectl is also running on every node in the cluster, and that's this thing that manages like virtual IP addresses and net filter rules that make the networking work across a cluster. So that's enough. I'll go into more detail on those as we need, but for the attacks here, we're going to be attacking a Kubernetes cluster from the perspective of a pod, from the perspective of container breakout. So in what we're doing, we're going to be demonstrating attacks on Kubernetes manually, but we're also going to be using a free open source tool that we make it in Guardians called Kubernetes. And Kubernetes means helmsman in Greek. Kubernetes means pirates in Greek. So you can find Paratis in Kali Linux, but actually always check the GitHub page for the latest release, because it'll be a lot more capable usually than, because we have a somewhat frequent release cycle. So let's get straight into it. If we want to attack Kubernetes from a compromised node, the first question is like, how does an attacker kind of get to that compromised node? And that's the main thing we're going to talk about today, is basically how an attacker is able to break out of a container. So there are a couple mechanisms by which they'll do it. The first is, if they've got an exploit that can lead to container breakout, then that'll get them from being inside a container to being outside the container or on the node. Another way, we're gonna discuss that first. We're not gonna demo it. The thing that's not as much fun about that kind of container breakout is that things get patched constantly, and so when you want to try this yourself, it's harder to try, because by the time you got your hands on the exploit, sometimes or often things have already been patched. The next kind, which is kind of always there unless the cluster has been defended against it, is that we can run a pod that has too much privilege. Or if an attacker happens to compromise an application running in one of those pods, then the attacker ends up with the ability to break out of the container in that pod. And then, of course, the thing would be remiss if we didn't say, an attacker might also just phish an engineer that has login access to the node, or for that matter, that has the ability to deploy pods that have too much privilege. So just to talk about exploits for a second, there have been a good number of container breakout exploits. There were 5 just in the first quarter of this year, and 3 in the month of March, exploits that had the potential for breakout. The funky thing, the thing that a lot of people don't realize or talk about, is that anytime there's a vulnerability that lets the threat actor either get code execution in the kernel, or modify the right kernel data structures, that can lead to container breakout. Because at the end of the day, when we say you're in a container, it's kind of like as much as the cloud is this somewhat amorphous term that has that doesn't convey that much, or conveys the wrong ideas. Container in some ways is the same thing. So if you're a program running in a container, you're not in what we're used to with virtual machines, where it's like, okay, there's all these, this is done all the way down to the CPU layer. There's these kind of boundaries that make it hard to, that make it so that you really are kind of on a different computer than the other virtual machines that are on a system. For a container, all of the programs that are on a Linux system that are running in containers, they're all still programs on the Linux system. The issue is basically that they've been given these different namespaces that change their view and, in many ways, access to that system. So there's a network namespace that we'll talk about later that says, the programs that are running with this network namespace instead of the main system's network namespace, they get their, they don't see the same network cards that everything else in the system sees. They kind of have their own virtual network interfaces and IP addresses and so on. We'll talk about this some more. But if you want to look at these most recent 5 container breakout vulnerabilities, you can find links here after and go take a look at them. So we're going to talk about that second case, the overprivileged containers, because if you were to start up a Kubernetes cluster yourself right now, if you didn't configure any kind of admission control, if you didn't configure a security control to stop it, anybody who can create a container is allowed to. Anybody who's able to create a pod can create a pod that has too much privilege. And that'll let them compromise the node and sometimes compromise the entire cluster. So here are 3 examples. We're going to talk about privileged containers on another slide. We're going to talk about host network containers. And then finally, we have containers that mount the node's file system. There are when we were talking about volumes earlier, someone who defines a pod that has a volume in it that mounts the node's file system. Host path volumes are one of those kinds. We'll have access to the node's file system, and that gets you quite a bit. So we'll see some of this through demo and slide. So I'm going to talk about this and then show it to you. So privilege containers are really powerful. A privilege container basically has a few things it can do. One is it can mount the entire /dev or device tree instead of just the small number of devices that normal containers launch. And I'll show you that in a second. It can also insert a module to the running kernel if your threat actors, has the chops and the time to create your own kernel module or to buy one. And then finally, a privilege container has access to all of the root capabilities, all of the root special powers, rather than normally when you're in a container, a bunch of the root special powers go away. And by go away, they're configured by default to not be allowed for you. So creating a privilege container, this is kind of a reference. I'm going to show you what this looks like, but this is a manifest for a privilege container. I'm also going to show you another kind of privilege container that also uses the host's PID or process namespace. So I'm going to show you that in a second. Rather than dwell on those slides, I'm going to show those. Be showing you those same files, but in a demo. So I record all of my demos, and so you're going to watch me like hit play and pause here. So let's see. So first we've got that pod manifest. This is just a normal pod manifest. This is not a privileged pod. It just says I want to start a pod named pod. I want to do it from this container image. So we can use kube control create and feed it that manifest. And we're going to exec into we're going to run a single command in the pod, which is to list /dev. And what we see is this small number, a little more than 10 devices. This is what a normal container looks like. So now, by comparison, let's do a privilege container. So here's our kind of small number of devices. Let's do the same thing, but here we go. This is that manifest we were looking at on the slide. This is a container. We're going to call it priv, and we're going to set its security context. This is the added 2 lines, privilege true, and this lets us create a pod that has a privilege container in it. And so we'll create that, and we'll add a shell to it. We're going to exec into it. And in here, I can look at the hostname file. It says priv. That's going to come back to you. If I look at /dev, wow, it's a whole page of devices, not just 12 or something. And in there, one that's particularly interesting is you see dev SDA, which if you're a Linux head like me, means it's one of the SSD disks or one of the hard disks. So let's go and mount that. We're going to mount that SDA onto /mount read write, and now I'm going to chroot into that. I'm going to start a shell and set the shell's root of it, the root of the shell's file system to /mount. So this will feel like being on the host. So when I cat out etc hostname, now I see that I'm seeing, the node's hostname file, not the containers. So let's just demonstrate we were here. We'll write a file real quick. And so this is kind of the first style of just using a privileged container to break out, because now I've got file system access on the node. I'm going to do this via a second mechanism in a second. I'm going to clear my screen, and I'm going to create a privileged container. But also I'm going to say that this pod, in this pod, all the containers, when they look at the process tree, instead of seeing, just like 2 or 3 processes the way you normally do in a container, we're going to see all the processes that are on the node, that are on the host itself. So I'm using the host process ID namespace. So that's what this container is going to do. Host PID, same privileged security context. Let's create that pod. And we'll exec into it real quick. And now cat out etc hostname. Normally nothing, but now we can use NSEnter. And NSEnter is going to say we want to enter the namespace. So we're going to say that we are going to start a shell, and that shell, instead of using the same mount namespace as the pod, the same view of the file system as the pod has, we're going to say that this shell should now be using a different namespace. It should be using the same namespace of the same mount namespace as process ID 1 on the host. And process ID 1 on the host is, systemd or init, but it's kind of the core, the root namespace. So it's like being outside the container for the mount namespace, which means now when I say show me etc host name, I see the nodes file. So it's kind of a second trick, and this kind's actually a little more convenient in some ways. I'm going to show you that if I look at that proc file system, for every process in the namespace directory, you'll see that each of its namespaces is kind of a link to a namespace. If you look at those, you'll see the namespace numbers, and that we just use the mount one here, and we already used the PID one, but we could use the others as well. So at this point, what I want to do is pause here and switch back to slides and talk real quick about host network pods. So host network pods are ones that allow all the containers in them the same way we just use the host process ID namespace. The host network pods are one where instead of the pod getting its own IP address and its own view of the routing tables and all that, it's just going to use the same ones that the host has, which means it's kind of going to be a container like we're used to, except that it will have except instead of using different namespaces for a whole pile of namespaces, it'll use different namespaces for everything except for the network. The cool thing about that is it means that the container, when it reaches out to the network, when it makes connections out to the network, instead of following whatever kind of the routing from the container out to resources would normally be, it'll be using the node's network card, the node's IP address, and that lets it bypass a bunch of the workload identity type restrictions, type technologies that clusters have nowadays, or the clusters often have in cloud providers, where you're on the cloud provider, and if you're in a pod and you try to reach out to the cloud provider's metadata API and say, hey, I'd like a token for my cloud account, each of the cloud providers has now made a default using tools similar to kube2im, GKE with workload identity and so on. They're using tools that'll intercept anything coming from a pod, from a container that's in a pod, and say, oh no, wait, I don't want to give you this. I don't want to give you the metadata API answer that you'd get as if you were the node. I want to give you one that's specific to your container. However, if you use a host network pod, you're able to kind of bypass this kind of protection. So we're not going to demo this right now, but it's really pretty. It's simple that we're just adding the same way we added a host PID true. In this case, we use host network true. Okay, so what have we shown so far? We've shown that we can get node file system access, and now what can you do with that? And there are a few things you could do. The first is this is kind of a table of contents slide. So the first is you can steal authentication credentials from that are used by the nodes, more privileged control plane elements like the kubelet and the kube proxy. You can also go and steal secrets that are in other pods. You could run programs in the node. You can create what are called mirror pods, where you're basically creating pods in the cluster that didn't exist already. And I'm going to show you the first three of these. So we're going to do this. We'll use the kubelet's authentication credentials. And we're going to demo this. Basically, the kubelet has its own key pair, a client, basically a client key and a client cert that it uses to authenticate to the Kubernetes API. We can steal that. If we do that, a lot of Kubernetes versions, all the ones before version 1.22, basically permitted the kubelet to read every single secret on the cluster. And if they could read every single secret on the cluster, that meant that they got all the service accounts in the cluster. So we'll demonstrate that real quick. So let's go again now, and we've got this. I've created another pod, and this is just a privileged pod, nothing different. I've changed the container image though to copy Paratis onto the into the system. So we're going to exec into that pod. we'll mount dev SDA1 the same way we were before. So we're mounting the nodes file system. Before we chroot, we're going to copy Paratis into the nodes user bin. And we'll also take Paratis. It has a cool feature that if you take Paratis and call it kube control, it'll work like it'll be kube control because it uses kube control's library. So we'll chroot into a little bit of a fat finger there. I left the space out, and we'll chroot into /mount. We'll run a bash shell, and let's go look in varlib kubelet. And I'm going to clear the screen. And inside varlib kubelet, we see a few different directories, a few different files and directories. One of them is kubeconfig, and that kubeconfig is the thing we were just talking about. That's going to give us the credentials for the kubelet, a client. We're going to see a client key data and a client certificate data string here. So the client key data, the client certificate data, and those are just base64 encoded versions of those files. So what the cool thing is that I don't have to go and decode that. I don't have to go in base64 decode that and write it out. I can just go and say, hey, let's use kube control, and let's tell kube control to use for its kubeconfig file, for its config file, the kubelet's kubeconfig file. Now I can say get secrets, all namespaces, and give them to me as YAML, which means I'm going to see all of their details, which means their contents. So I can go and hit that. And what I'll find as I page through is this is a whole bunch of these service account tokens. And so if I grab one of those tokens, I can actually go and base64 decode it and use it. So let's do that. I've just chosen one of the Kubernetes control plane components at random. So I'm going to take that. That base64 string. I'm going to write it in temp token. Now I'll need a couple things, a couple of things from the kubeconfig file that I saw there. So one is I need that certificate authority data. So I just have a little one-liner I wrote to write that to a file. I'll grab the server, the API server's IP address and port, and stuff that in a variable. And now I can run kube control. Say use that server, use that certificate authority file, and use the token that we just got. And the token I'm going to have to put on the command line. So I'm going to cat the file out and then base64 decode it. And then I can say, what do I want to do with that? So I'm going to do get pods. Cool. Let me get pods. I can say get secrets. Oh, same thing happened as my practice run. We just for a second there, let me just yank us back to playlist so I can just show you that. And I'm just going to put that up in just a second. I just edited my video a little too tightly. It's crazy because there's just one little part I want to show you, and it's literally just the output of that one command that falls off before the end. Okay, we are gonna, oddly, with recorded demos, you're not supposed to have a demo gods, but we have. So short version, the output we got back was like, hey, this attach detach controller service account isn't allowed to get secrets. But the cool thing is, in telling us that, it at least told us that we were successfully impersonating that service account. So the neat thing is that we were basically in that demo, we're using the kubelet's credentials to get a list of all the secrets and their contents, and those secrets had all the service account tokens. There would also be all the other secrets that are used by the cluster anyway. Like there might be passwords, credentials to other services, all the different things that are all the different configuration that's pushed in as a secret. So it's kind of cool. It's really, really useful, and that's what you get as soon as you can achieve even any kind of container breakout, even including just file system access. So let's keep going with the slides, and we'll be doing another demo in a sec. So the kube proxy runs on every single node. It gets a service count token, and that service count token is also accessible on the file system. So if we're able to read the file system, you remember when we were looking at that var lib kubelet directory, we saw a pods directory. Well, the pods directory has for each of the pods, and they're not given nice names, they're given these kind of long, hash style strings. And inside each pod's directory, it has a volumes directory, and the volumes directory has any volumes that have been mounted in, and every pod by default gets its credentials, gets API access credentials, service account token mounted in, and so we can go and grab them straight off the file system. And that's one of the things that we can do, and we'll be demoing that shortly. But before we do, let's first talk about how I can take that node file system access and turn it into actually running a program on the node without being in a container in any way. So what I'm going to do is I'm going to basically add just anything I can do that where writing to the node's file system gets me access, I can do that. So I'm going to write a crontab file, and that crontab file is just going to include a quick little script, and that script will be running a C2 agent for us, but only if one isn't already running. So I'm going to demo that now for you. And let's go back in. So this is, I've got a sliver C2 similar to Metasploit. Metasploit's interpreter, just some way of having a more interactive program that runs. So what I'm going to do is I'm going to pull down a copy of the, sorry, I'm going to pull down the sliver C2 agent and make it executable and then copy it into the node's file system. This is just from a privileged container from where we'd already been mounting the file system. I'm going to write that script real quick. And that script's going to say, hey, as long as there isn't one of these node C2 things running already, please run it. This will stop us from having, a new one launched every minute, because that's annoying. And so what I've done now is I've trued it in. I'm going to edit the crontab file, and I'll add a quick little line to the crontab file that says, hey, run this launch MTLS, launch my C2 thing. And now I've switched over to another screen where I have a sliver waiting. And I know this is a little smaller font, but I've made it like this so you could see, some of this fit on the screen better. So we got a connection back, and we'll engage with that connection. We'll run a shell, and in that shell, I can ask for a list of processes. This definitely isn't a container and lots of processes. And now I can run Paraties, and Paraties says, hey, I've found the kube config file for the kubelet, so we could use that. I've stored it. And also I walked around the file system, just like we were just showing that slide, and found all the service account tokens. And so if I list the service account tokens that Paraties has, I see those, I see each one of those has been automatically stored and we can use. And the cool thing about that is that we've written this feature in Paraties where, well, first I'm just going to use the kubelet cert and say, I can say, what is the kubelet allowed to do? It's allowed to list all the secrets. Cool. We've created this kind of cool feature called try all, where Paraties will take every single service account token you've got, even if that's like 50, and you tell it what command you want to run, what kube control command you want to run, and it will try all of them until one of them works. So I can say, hey, do me a favor and list all the secrets, and it tries that command as each of those service accounts one by one until it finds one that works. And you can use that to pull a specific secret. I'm starting to run a little short on time, so we have an optional demo I'm going to leave out, but we'll just talk a little bit more about what you can do with node access and then talk defenses. So if an attacker can run a program on the node, what else could they do? They can steal some of the secrets that are mounted into pods as environment variables. We might be able to do that with that host PID that we had with one of the containers we had earlier, but you could even inject yourself into the different containers. The attacker could also go and try pulling the credentials for the node's Cloud IAM account and use that to access bucket storage that's available to the node. It can steal credentials that are for the vault. The cool thing, and so we talked about environment variables. The cool thing about pulling the node's cloud credentials is that that's going to be really, really useful. And you'll find next time you're on a virtual machine in the cloud provider, or you're even, even if you're in, a function as a service or, serverless, hit this URL. It's the metadata API. And if you read the docs and the metadata API, you can find out that kind of with 2 curl commands, you can pull a service count token that belongs to either the node that you're on, the instance that's backing whatever service you're using, or if there's a tool in the way, like that kube2 IAM I was talking about earlier, then you'll get something else. So the cool thing is, I've got a demo we're not going to be able to do, but basically, it's where I can take the node's credentials. Maybe I'll upload it with YouTube and then put it into my into the Slack channel. But I can take the node's credentials and use that to read the COP state store bucket. If this Kubernetes cluster was created by COPS, it has to store a state store somewhere, and the states, if it stores it as default in a GCS or an S3 or what have you bucket, then I can get credentials for the entire cluster, and that's what's in my demo. So I want to talk defenses though. The most important defense that you've got here, the thing that would have made all of the like overprivileged containers or overprivileged pods break, and what will also break a number of the exploits that get you container breakout, is an admission controller. And an admission controller basically says, you're going to apply some policies or some standards or some rules to what people can put on your cluster, whether it's, and those rules can be, you can make rules for pods, you can make rules for namespaces. Those rules, if you use, so pod security policies, which are on their way out and being replaced by pod security standards, those are in tree, come with Kubernetes. But there are more powerful and more capable, more granular ones. The kind of the gold standard, but has a higher learning curve, is OPA, Open Policy Agents Gatekeeper. And another one that's easier to use but still very powerful is Kyverno. And what you can do with all these admission controllers is you can say, hey, I'd like to make sure that you aren't allowed to, that people aren't allowed to create privilege pods. I didn't show you here, but you can actually put a pod onto the control plane nodes, just with adding a few lines, adding a toleration that says that you'd like to be permitted. Your pod should be permitted to be on a control plane node, and then some node affinity that says you'd like to only be running control plane nodes. And the only way to really stop that is to have an admission controller that says, no, you can't create pods that are set that way. Another thing you can do that breaks a lot of the container breakouts are seccomp. So container breakouts, Docker has a default seccomp or system call filter. I better watch my time, has a default seccomp filter, but Kubernetes doesn't. In version 122, Kubernetes finally introduced a default seccomp filter, but it's an alpha feature, so it's not available, or it's not turned on, and it's not available unless you activate the feature gate, unless you just basically have to do a little extra work. But having a seccomp filter, even just the default Docker one, which is very loose, in a class I teach at Black Hat, we make much tighter ones. But even just using the default one actually breaks a ton of the container breakout exploits. Another thing you can do when you're ready to kick it up a notch is you could use the security profiles operator. This isn't part of Kubernetes by default, but it is made by a Kubernetes SIG that's part of the Kubernetes organization. And it lets you create security profiles like seccomp filters or AppArmor profiles or SE Linux profiles, and distribute them more easily to the cluster, make that, because it's not that easy to use them right now. Two more things you can do. One is you can, if you have some access or secrets that are particularly sensitive, that are needed by some of the pods that are on your cluster, you can make it so that those pods run, well, best case, you run them on a separate cluster. But if you can't do that, which many times we can't, you can say you'd like them to run on dedicated nodes, so that a node breakout and a recent version of Kubernetes won't let somebody get to those anywhere near as easily. And they're node affinity features, and I put a nice reference link. The last thing you can do, and this is huge, is upgrade your cluster. Kubernetes releases really often. It used to be 4 releases a year. It's not quite that many, but it's still releasing really often. And to get a lot of the best defaults and a lot of the best security features in Kubernetes, you need to upgrade your cluster, or do cattle not pets thing and replace your cluster and do that upgrade or replacement often. Privilege pods became a lot less useful in more recent versions. Version 1.22 deprivileged the kubelets, so the kubelet couldn't pull all the secrets. Recent versions also took those service count tokens that used to be mounted as normal volumes, and made them projected volumes that were backed by tempfs, and so they weren't. Those are visible to the first style to the second style of breakout I showed you, but not to the first style. Anyway, big deal is Kubernetes defaults getting stronger and stronger. There are a lot of great InfoSec people in the Kubernetes project. You can join them. They are a friendly bunch, and at least take advantage of what they're doing. Go take a look at the project. Lastly, come find me in the hallway Slack channel. Go look at Paratis, see if you want to help in its development, and follow me in Guardians on Twitter.